Hi everyone. Today we are going to discuss about the problem of robot bounded in circle. This is little bit tricky problem, but it's very easy. I'll try my best to explain this in a very easy manner. So let's start it. So this is the problem statement. What it was written that on an infinite plane, a robot initially stand at 0, 0 coordinate, right? Let's suppose visualize there's an infinite plane and the robot stands at 0 and 0, 0, which faces towards north. Suppose I am trying to draw a coordinate here. So this is north, this is south, this is east, and this is west, right? So my point is robot is now stands here. Cool. Robot is now stands here as per the question. Now the second point is uh, if the robot can receive one of three instruction. If it's G, on that case robot will move straight by 1 unit. If this is L, so on that case it will turn 90 degrees to the left. Okay, matlab it will not move in this case. Okay, it will just change its direction to the left. Okay, visualize yourself in the place of robot. It will be very easy for you on that case. And suppose for R, it will turn to a 90-degree right. Okay, concentrate on this line. The robot performs the instruction given in order and repeats them forever. Means suppose any instruction is given like GLR, on that case it will be repeated on an infinite pattern. Okay, so on that we have to return true if and only if there exists a circle in the plane such that the robot never leaves the circle. It means suppose in a plane we have a circle, so the robot will never leave this circle. Matlab, the robot can move like this in this circle in a loop, but it can't leave this circle on a infinite plane. Okay, so this is our problem. So now let's discuss about the test cases. Instruction that is given to us is GGLLG. Okay, matlab suppose the robot is at 0, 0 coordinate. GG means for the first time we are going to fetch the instruction, fetch this character G. So the robot will move to the first 1 unit, then again it's G. So robot again will move to this another 1 unit. Now what is written that it's L, means suppose this is the head of the robot. So now it turns 90 degree. It turns 90 degree to the left. That means robot is now pointing towards west. Okay, and again turns left, right? So again I'm going to turn left to 90 degree. Now it points towards south. Okay, again GG. So for that, first robot again will move to the first 1 unit, again next 1 unit. Okay, and it is now the difference between is that in this point the robot face towards north direction. Now it face towards south direction, right? Again it's gonna repeat G, G, L, L, and G. So suppose I'm gonna repeat this. So again G 1 unit, again G 1 unit, again it turns to 90 degree left, again it turns to 90 degree left. So means this is the my pointer right now. Again it's G and G. So what you guys can see from here is robot is in a circle, right? It is in a circle. So sorry for my bad drawing. It is in a circle of 2 unit. It is in a circle of 2 unit. Why? See, it first moved towards 1, 1. 1 plus 1, 2. So it is in a circle of 2 unit where it moves in an infinite manner. This is a loop, right? It moves in an infinite manner in a particular loop and it never leaves this circle. So in this case, we are going to return true. Okay, let's take another example when I am going to return false. Now let's understand the another example of GG. So for the case of GG, suppose robot is at 0, 0 coordinate, again will move to straight, again will move to 1 unit in a north direction, right? So in this case, we are going to return false. Why? It moves infinitely in one direction. It moves infinitely in one direction, and we are never moving back to the origin or there's no possibilities to move back to that point as well, right? So what we can conclude that we have, by observing the test cases, the very first thing that we have concluded that to get the our value as Boolean value as true, the robot must return at origin. The robot must return at origin means if the robot, after traveling a certain path, it returns at origin, it means it will never ever leave that circular path, right? So the first condition that we need to satisfy is x equal to 0 and y equal to 0 after traveling a certain amount of path. And suppose our robot is pointing towards north only. So on that case, we will going to return false. Means suppose my direction is a variable and my direction at the end of the entire code is equal to north only. On that case, we are going to return false, right? So for true condition, we have to just check if this is not equal to n. On that case, we will return true. Okay, so now we are going to implement this two thing in our code once, then we will code it in Java. So first, let's suppose we already take one variable as n, that is direction. We consider our direction is n and the coordinate as x equal to 0, y equal to 0. Okay, suppose this is our instruction. Let's suppose our instruction is what? G, L and R. Okay, let's suppose this is our given instruction G, L and R and we have to return some Boolean value, right? So suppose our robot is pointing out in this point. So on that case, and we fetch from this string a character G. So if my given character is equal to G, on that case, we will increase the x value by 1, isn't it? We will increase the x value by 1 because we have already have the direction as n. Matlab, when we have G, we are going to increase the y value depend upon their direction. Suppose my direction is overwritten by E or W or S, we will increase the y x value based upon that. Sorry, this is y plus plus. Okay, this is y plus plus. Very sorry. Now let's understand if suppose we fetch the value L. Okay, suppose our given string is equal to L. On that case, suppose my robot is now north direction. Okay, the head is now towards north and suppose I have the order L. So on that case, I will return to west. So suppose direction is equal to N. On that case, it will return us W. Matlab, if we are facing towards north and L and the order given to us is L, on that case our direction will be equal to west on that case, and that is similar to S and E. You can draw the coordinate and you will understand this better. And for right, the same thing will happen. We will change the direction manually. Now what we are going to return at the end, we are going to return x is equal to 0 and y equal to 0. This is our condition. If the robot returns back to the origin, on that case it must return true, or this is or. Okay, or if direction is not equal to n, on that case it will return the Boolean value of this expression. If this or this is true, we will return true. Otherwise, we will return false. Okay, so now let's see the code. Okay, so this is our code. As I mentioned you earlier, that firstly we will check the we will assign one character value, means the direction to north. Then we will assign x and y value. Next, what I have done, I have find out the length of this particular instruction string, and I iterate through that complete instruction. And I am fetching one data, means the character one by one by using char at I. So if the direction equal to n, means towards n, so upar ja raha hai, so on that case I am increasing the y value. If this is towards south, I am decreasing the y value क्योंकि नीचे जा रहा है. Now this is east, so I'm increasing the x value, that is positive axis, and otherwise I am decreasing the x value because of west. Okay, now suppose the direction is equal to L. On that case, I am if this is direction equal to north, on that case I am returning direction as west. I'm telling you I am explaining you already with the help of the robot head, and the same thing happened in south, east, north and south, right? You can draw, you will understand this better. And same for right. If this is north, imagine if you are facing towards north and the right instruction is given to you, obviously you will turn towards east, right? So I have done the same thing one by one, and next I have written the case that I have told you. So this is all about the code. I hope it you understand all of the you understand the code and problem totally. So thank you.